Okay, folks, chapter 2 is going to talk about what are the ways that we organize data when we're doing research. So one of the first things we're going to talk about is what's called a frequency distribution, and we're going to look at nominal level data. Remember that nominal level data is data that has a name. It can't be ordered, and it doesn't have an equal distance between each of the potential options. So we use formulas and we use statistics in order to organize raw data, and then we use that also to test our hypothesis. But raw data is often difficult to synthesize and make any sense of. One of the ways we can make sense of that is to use frequency tables. And it makes it easier for us to look at it and to understand it. So here's an example of a frequency distribution of nominal data. So look here, what they're measuring is responses of men to a hypothesized auto theft. And there are 4 options here. They could confront the thief physically, confront him verbally, shout for help, or call the police. So you can see that our answers here are organized into a chart, right? And we've got our responses in the first column, and in the second column to the right here, the number of people who chose that particular response. So the F in italics there stands for frequency. So for example, 25 people chose to verbally confront the thief. You might notice at the bottom, I don't know if you could see here. Hold on. Right here. Right? We see that N equals 50. Okay? N is the number of people in our sample, right? 50 people answered these questions. So we could use this information and look and see what's the most common response, what's the least common response. And remember that this is nominal level data because there's no order here to this data. Okay, so here we have, this comparison lets us clarify the results, add information, and allow us to compare. So now we've got the same response. How would you respond to an imaginary auto theft? But now we break it down by gender. Okay, so now we have our responses, how many males responded each way and how many females, right? And that allows us to make some comparisons here. So we could see that the most common response for women is to call the police. The most common response for men is to verbally confront the thief. So another thing we might do with our data is calculate proportions, percentages, and rates. So this allows us to compare things from different groups, right? So imagine, we want to compare a crime rate, for example, right? We want to compare how many murders happen in, Massachusetts with how many murders happen in Vermont. Well, we have to take into account the population. So how do we compare groups of different sizes? Well, we can use a proportion, which is the number of cases compared to the total size of the distribution. Okay, so if we think about the data we had over here, right? 3 females out of 50 said they would physically confront the thief. We can do a percentage. That's the same as the proportion times 100. Or we could calculate a rate. And crime rates are generally calculated per 1,000 people or per 100,000 people. So let's look at an example here. We have a table representing attitudes towards capital punishment for people convicted of murder for men and women in the U.S. from 2010. Okay? So it's asking us to find the percentage of men who are in favor of capital punishment, the percentage of women who are in favor, the proportion of men who oppose, and the proportion of women who oppose. Okay, so, sorry, I thought the answers were on the next page. So one of the ways we would do this, right, in order to find the percentage of men who are in favor of capital punishment, we would take 239 divided by 341 and times that by 100. If we wanted to find the percentage of women who are in favor of it, we would take 243 and divide it by 412 and times that by 100. For proportions, we're going to do the same thing. We're just not going to multiply it by 100. For men who oppose capital punishment, it's going to be 102 over 341, and we would reduce that as far as possible. And for women, 169 over 412. So here we have the attitudes of people towards legalization of marijuana and attitudes in 1970 versus 2010, right? So we would do the same problem here, the same approach, okay? So we're just going to look at one of these. The percentage of Americans in 1970 in favor of legalization would be 65 divided by 521 times 100. The proportion of Americans in 2010 who oppose it would be 408 over 653. Okay, here's some other practice problems that we could do. So what I would encourage you to do is to just kind of look at these, pick a couple of them, practice them, make sure you understand how these numbers work, okay? It's really important to have an understanding of how numbers work so that when you're looking at them, you could kind of tell if something looks like it's off. Okay, so another thing we can do is we could create frequency distributions. We could create a simple one and we could create a grouped one. So a simple frequency distribution is a tally with both frequencies and percentages, okay? When we use nominal level variables, we don't have to list them in any particular order. So remember, an example of a nominal level variable would be sex, male and female. You could list it male, female, you could list it female, male, okay? If we're using ordinal or interval level variables, right, these are ordered. So you have to put the list in order. You could start with the lowest to go to the highest, or start with the highest and go to the lowest. So here we have career preferences shown 3 different ways, right? So career preference is a nominal level variable, so we could put it in whatever order we want. And you notice there's 3 different options here. All of these are valid. Okay, attitudes towards televised criminal trials, okay? This is an ordinal level variable. We do want to put this in order, but we can do it in 2 different ways. We could start with, we could do it in 2 different ways, but right here they're showing you a wrong way and a right way. So on the right, you can see that it goes in order. Strongly, somewhat, slightly, slightly, somewhat, strongly, okay? That's really important. On the left, you could see it's not in any order. Now, what you could do with the one on the right is you could start with strongly unfavorable, somewhat unfavorable, slightly unfavorable, slightly favorable, somewhat favorable, strongly favorable. You could do it in the opposite order. That would also be fine. Okay, so for practice here, 20 offenders are asked at what age they committed their first offense. And here we have our ages, okay? So how would we put this in a simple frequency distribution, including a percentage distribution as well? So here we list the ages, and we put them in order. 2 people were 12, 3 people were 13, okay? And then you can see to the right, that means 10% of the group was 12, 15% of the group was 13. Okay, sometimes interval level variables spread over a wide range. You'll see when we look at some of the NIBRS data, that if we were to look at age, it could range from 0 to 99. So sometimes what we want to do is do a grouped frequency distribution. We want to take interval level scores and spread them over some ranges. Each category or group is called a class interval. These are smaller categories or groups containing more than one score. My apologies for coughing in your ear. The size of the class interval is going to be determined by the number of score values it contains. So this is a special way of categorizing our data. We want to think about how many categories we want to use, and we want to think about what patterns we're looking for. So the size of the class interval should be a whole number, and the lowest score in the class interval should be some multiple of its size. So here's an example, okay? We could list this out as 1 year, 2 years, 3 years, or we see here we have them grouped in 5-year groups, right? 1 through 5, 6 through 10. You could see to the right of that is the number of people, the F, the frequency, and to the right of that is the percentage. Okay, another thing we might look at is what is the middlemost score in a class interval, okay? So here we've got this range, right, of 1 to 5. What is the middlemost score, okay? What's the score that's in the exact middle? And we call that the midpoint, right? So we take the lowest score and the highest score, add them together, and divide by 2, and that's your midpoint. You guys probably remember that from high school math. Sometimes it also helps to present your frequencies in a cumulative fashion. So that's the total number of cumulative frequencies, or the total number of cases having a given score or score that is lower, and that's represented as CF. And a cumulative percentage is the same thing, but with a percentage. So let's look at what that looks like. You can see we have our class intervals here on the left, okay? So how many people are in the group from 95 to 99? That's 6, right? It's 4.23% of the distribution, okay? Now you'll see cumulative frequency and cumulative percentage. 142 people are 99 years of age, scored a 99% or lower, okay? 136 people scored a 90 or lower, 94 or lower. 132 people scored 89 or lower. Hopefully that makes sense. They won't always make use of class intervals of equal size. Here you could see one that I did for a project that I did for a class. Okay, you can notice age, 25 to 29. It's a 4-year period. And then we have 10-year period, 10-year period, and then 50 plus. Another way of organizing data is to use a crosstab. Sometimes researchers want to do more than just describe the distribution of some variable. They want to tell us why individuals fall at one end or the other. So we need to expand our tables into 2 or more dimensions. A crosstab presents the distribution, the frequencies and percentages of one variable, across the categories of one or more additional variables, usually the independent variable. Okay, so let's look at an example. Okay, here we have relationship between a victim and an offender in a homicide based on the victim's sex. So in intimate relationships, right, 496 were men and 1,473 were female. This is a crosstab. You've seen tables like this your whole life. You just didn't know they were called crosstabs. Okay, you can also do this sometimes and use row totals and row marginals, okay? Well, you would have row totals because you have the total there, and then you have the your row marginal. Okay, so a marginal distribution is the frequency distribution of each variable separately along the margins of the crosstab. So the right margin of the table provides a frequency and percentage distribution for victim-offender relationship. Okay. So we can also add percentages in, and that sometimes gives us a little bit more, better meaning. If we look back to this table here, 1,473 out of 3,335, sometimes a percentage is easier for us to wrap our heads around. So row percents are taking the frequencies in each row divided by the number of cases in that row. Okay, so for here in our table, they represent the victim sex distribution within each type of victim-offender relationship. Column percents do the same thing, but for the columns. Which one you choose to do really depends on what you're talking about. If your independent variable is on the row, use row percents. If the independent variable is on the column, use column percents. Okay, we can also think about ways to present our material in a graph. Okay, we often tune out columns of numbers, but graphs are pretty easy to look at and kind of grasp the meaning of the data pretty quickly. So here, for example, we have a breakdown of marital status of prisoners sentenced to death, right? So we could see 54.4% were never married. Okay, so pie charts only allow us to have a few categories, but bar graphs and histograms can accommodate any number of categories, and you can use them for any level of measurement. What they can show us is the effect of one variable on another. And these are used much more often in criminal justice research. Okay, and they follow a standard arrangement. On the x-axis are the score values or categories, and the y-axis is percentages or frequencies. So bar graphs and histograms are often used interchangeably, but there is a difference. In order to be a histogram, it has to be continuous measurement, whereas a bar graph displays usually nominal level variables. So here's a bar graph, right? The percentage, it's that same data we just looked at. What percentage of homicides are intimate partners? What percentage are family members? What percentage are acquaintances? Right? So there's no continuous relationship across those variables, so we would use a bar graph. Okay? Here is the same data broken down by male victims and female victims, right? A lot easier to look at and understand and kind of pull some meaning out of than the table, than the crosstab is. Okay, we can also use frequency polygons. They stress continuity along a scale, and we use them for depicting ordinal and interval level data. So here's an example one, right? We have police scores, right? And we're plotting the scores, and then we're just drawing lines between them. We're playing connect the dot. The shape of the polygon is going to help us visualize, frequency polygons help us visualize the shapes and forms taken by the data. So some are symmetrical. They have the same number of scores on the left as on the right. Some are skewed, okay? If we have more extreme cases in one direction or the other, they're skewed. That can be in terms of how peaked they are, and we refer to that as kurtosis. Okay, a very peaked polygon is leptokurtic. A very flat one is platykurtic, and neither is mesokurtic. Okay, the normal curve is mesokurtic. A distribution can also be skewed to the left or to the right. Right, so here's an example. C is the normal curve. You're probably used to seeing that. It's a bell curve. And here we see negatively skewed, positively skewed, and symmetrical. Okay, a line chart is a special, a frequency polygon is a type of line chart. A line chart displays changes in a variable or between variables over time, okay? This is helpful for looking at patterns over time. So here we go. Here's the homicide rate over time, right? So it's plotted for each year, right? And then it's connected. So that's a line graph, right? We also might have a map. You can, there's actually software you can use where you go in and it shows you a map like this. And you decide how you want to color code it, and it will do that for you. So here we're looking at homicide rates. Notice the Northeast is very low. Okay. The General Social Survey also shows us something. How often, this is showing us a crosstab, showing us the relationship between people who favor or oppose gun permits, okay? Whether or not you favor or oppose a gun permit, and how that relates to how often you read the paper, okay? So people who read the paper, 148 people who read the paper every day also favor gun permits. This is going to make a little more sense to you when we get into the data and get into SPSS. Okay, that wraps up chapter 2.